Today's topic at hand is going to be equivalent fractions and just getting a little bit deeper into it and understanding more about how to identify, how to look at a number line, how to look at objects to find equivalent fractions. So with that being said, let's go ahead and jump right into it. I have a few fraction strips here, and you'll notice also that I have them split into different pieces. So we're going to, for the sake of understanding how much of each fraction strip we have, we're going to pretend like on the left side of the fraction strip is where we're going to start, and on the right side, this is where we're going to end. So all the way down, we're going to do the same on each one of these. The start is over here on the left side, and the end is going to be on the right side. So if I talk about, let's say, 3 of the pieces, we're going to start over here on the left side, and then we're going to go just like we're reading a book to the right side. Okay, and it'll make more sense as we get started. Now, if I was looking at the first fraction strip, and I wanted to figure out how much I would have if I started here and I went to the center, I would have 1 out of the 2 pieces, or 1/2. If I went all the way to the end, I would have 2 out of 2 pieces, or 2/2, which is equal to the whole thing. Okay, and most of us probably understand that and can kind of figure that out. This part right here is going to be 1/2. This, if you combine both of those pieces, it's going to be 2/2, or 1/2. Now let's go to the next one where we split just a little bit larger, or split into, a little bit smaller pieces, making a bigger denominator. Let's go, if we start here, we go to this would be 1 out of 4 because there's 4 total pieces. So we have 1 of the 4, 1/4. Let's go to the next. Now we would have 2 of the 4 pieces. And then next we'll go down, and we're talking about all of the ones previous plus this one, it'd be 3 out of the 4. And finally, if we finished off and we had the whole thing, we'd have 4 out of 4, or again, 1/2. Let's look at the bottom here. I noticed these are split into even smaller pieces. So the first one would be 1/8. The next one would be 2/8, 3/8, and so on as we go all the way down the line. 4/8. We would have 5/8. Then we would have 6/8, 7/8, and then all the way down to 8/8, which again is the whole thing, 1/2. Now I want to call your attention. Here's the part where it gets a little interesting. I'd like for you to see, just take your eyes right here on 1/2. And I noticed all the way down on each one of these, I have something that's equal to 1/2. If I have this section of each one, I have 1/2 of each one. But notice they're written different because each fraction is split. Each fraction strip is split into different size pieces, but we can still figure out which one is the 1/2 mark. Let's take a look at the first one up here, and we have 1/2 up here. I want to look at the second one right here and figure out, 2/4 must be the same thing as 1/2 because it's equal and it's the same split as the top. Now the pieces are a little bit smaller in the second one, but 2/4 is going to be exactly the same. And then let's go down to the bottom and see, 4/8 also looks to me like it's equal to 1/2. Now with that in mind, do you see any others that could be equal to each other? Well, let's look if we have the whole thing here. On the first, second, and third, I do see something going on here, and I see 2/2, 4/4, 8/8. They all look like the numerator and denominator are exactly equal or the same thing. And we actually talked about this. When the numerator and denominator are exactly equal to each other, we have one whole every time. We have the whole thing. So no matter what the numerator and denominator are, if they're the same exact numerator and denominator, we'd have one whole. Let's look down here at 1/4. Now, I don't see it split up here, so we can't necessarily find an equivalent fraction with the first one, but I think I can find one for the second down here below it. We have 1/4 up here at the top, and we also have 2/8 below it. So 1/4 is equal to 2/8. The same, they're equivalent. Well, look over here as well. We have 3/4 and we have 6/8. So that means 3/4 is equal to 6/8. And you have to excuse all this drawing. I marked it up, I know, pretty bad. And hopefully you can kind of follow where I was marking. But let's take that to the next step further and look at a number line. All right, now that we have some number lines in front of us, let's see if we can kind of do the same thing going on. And with this piece right here, we know is 1 out of the 2. So I'm going to actually put that fraction down here below on my master number line down at the bottom. We'll see if we can get anything else. And we know that that one would be 2 out of the 2. All right, so we've labeled all those. It's only split into 2 pieces because we have one mark in the center. So it's split in half. We have 1/2. We have 2 halves. Let's go here and see. There's 1 out of 1, 2, 3, 4, 5, 6 pieces. So that would be 1 piece out of 6. And notice I'm just writing it below on the number line towards the bottom. This one right here would be 2/6. We would have in the middle 3/6. We would have here 4/6. We would have 5/6. And then we'd have 6/6. And we're going to put that down here. Let's see if I can take a look. Oh, this bottom one looks like, if I count them, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 pieces. So this one would be 1/12. The next one would be 2/12. We would have 3/12, 4/12, 5/12, 6/12, 7/12. You'd have 8/12, 9/12, 10/12. We'd have 11/12, and then over here I'm going to sneak this in, 12/12. Now, notice next to each other we have a bunch of equivalent fractions that are equal to each other, and we've just proved that with the number line. We have over here on this side, we have a whole 3 that are 2 halves is equal to 6/6 is equal to 12/12. Those are all equal to each other. We also have our halves right here in the center. We have 1/2, we have 3/6, we have 6/12. Those are all equal to just like half. We also have some that have 2 equivalent fractions. We have 2/6 from right here, and then we have 4/12. That piece is exactly the same. Maybe it's not the same size each individual piece, but the entire thing is equal to each other. The 2/6 is equal to 4/12. We also have these all are equivalent. So 1/6 is equal to 2/12. Those are equivalent. Notice we also have 4/6 is equal to 8/12. And finally, 5/6 is equal to 10/12. So I'm really hoping after seeing this, you start to see, well, now it kind of makes sense on why fractions can be equal to each other, because they're nothing more than maybe split into different size pieces, but it's the same amount. So with this in mind, I'm going to go ahead and enter this so we don't get too long. And hopefully you learned a little bit so you can visually see what equivalent fractions look like. And now you maybe understand, okay, that makes a little bit more sense to me. So now with that in mind, just remember, it's always a beautiful day in this neighborhood. Till next time, bye-bye.